Download this code from codegive.com, link in the description below. Certainly. Rust is designed to be a safe and efficient systems programming language, but like any language, it has its own set of anti-patterns that developers should be aware of to write idiomatic and effective Rust code. Below are 5 deadly Rust anti-patterns, along with explanations and code examples to illustrate each one. 1. Unnecessary cloning. Anti-pattern. Frequently cloning objects when references could be used leads to unnecessary allocations and performance degradation. Example. Rust. fn print_length, s, string. Let length equals s.len, // here, we are consuming the string and it's no longer usable. Println, length, length. fn main. Let my_string equals string from, hello, world. Print_length, my_string.clone, / unnecessary cloning. / println, my_string, / this line would cause a compile error because my_string has been moved. Solution. Use references instead of cloning when possible. Rust. fn print_length, s, and string, / accept a reference. Let length equals s.len. Println, length, length. fn main. Let my_string equals string from, hello, world. Print_length, and my_string, / pass a reference. Println, my_string, / this works fine. Dash. 2. Using unwrap, and expect, excessively. Anti-pattern. Using unwrap, or expect, without proper error handling can lead to panics in production code, making the application less robust. Example. Rust. fn read_file_content, file_path, and str-string. Let content equals stdfs read_to_string, file_path, .unwrap, / this will panic if the file doesn't exist. Content. Solution. Handle errors gracefully using pattern matching or the operator. Rust. fn read_file_content, file_path, and str-result string, stdio error. Let content equals stdfs read_to_string, file_path, / propagate the error. OK, content. fn main. Match read_file_content, example.txt. OK, content, equals println, file content, content. Error, equals eprintln, error reading file, e. Dash. 3. Excessive mutable state. Anti-pattern. Relying heavily on mutable state can lead to hard-to-debug code and concurrency issues. Example. Rust. Struct counter. Count, I32. Impl counter. fn new, dash counter. Counter count, 0. fn increment, and mud self. Self.count plus equals 1. fn main. Let mud counter equals counter new. Counter.increment. Println, count, counter.count, / mutable state can lead to bugs. Solution. Prefer immutable data structures and functional programming patterns. Rust. Struct counter. Count, I32. Impl counter. fn new, dash counter. Counter count, 0. fn increment, and self, dash counter. Counter count, self.count plus 1. fn main. Let counter equals counter new. Let counter equals counter dot increment, / no mutable state. Println, count, counter dot count. Dash. For ignoring lifetimes. Anti-pattern. Failing to properly manage lifetimes can lead to data races or dangling references. Example. Rust. fn create _ string, dash n string. Let s equals string from, hello. And s / this returns a reference to a local variable, which will be dropped when the function exits. fn main. Let s equals create _ string, / this will cause a compile error. Println, s. Solution. Use appropriate lifetimes to manage the scope of references. Rust. fn create _ string, dash string. String from, hello, / return ownership of the string. fn main. Let s equals create _ string, / this is fine. Println, s. Dash. 5 Overusing box for simple types. Anti-pattern. Using box for types that don't require heap allocation adds unnecessary complexity and overhead. Example. Rust. fn main. Let boxed _ box I32 equals box new, 5, / unnecessary heap allocation. Println, * boxed _ Solution. Use simple types directly when heap allocation is not needed. Rust. fn main. Let number, I32 equals 5, / no heap allocation needed. Println, number. Dash. Conclusion. These are 5 deadly Rust anti-patterns to avoid. 1. Unnecessary cloning, use references instead. 2. Excessive use of unwrap, handle errors gracefully. 3. Excessive mutable state, embrace immutability. 4. Ignoring lifetimes, manage lifetimes properly to avoid dangling references. 5. Overusing box, prefer stack allocation for simple types. By being aware of these anti-patterns and adopting best practices, you can write cleaner, safer, and more efficient Rust code.